All right, this is the second part of our September 10th turtle meeting. Cool. I'll just share my screen. Okay, cool. So my action point from here is to do a pie chart, the right language, a pie chart of all cases colored by in or out of Otamu, right?
Yes.
Cool. Cool. Okay. Next.
And also in the pie chart would be, actually, no, it's okay.
All right. Next. Adjusting. Okay, so this is after adjusting. Let's see what we get here. So we still have a good p-value for the ocean seasonality, which is good.
Which is great, which is what we are using anyway. Mm-hmm.
Yes, but let's see if that holds for Fibro. This, oh, by the way, this graph, right? You wanted this as well?
Yes, this is going to be the overall one, but I'm thinking I can, well, no, yeah, this one. Yes, this was going to be the overall graph. Yes, please.
Okay, cool. So
is there a way
anything-
you can send the graph individually somehow?
Yeah, of course.
Okay.
Of course. So maybe to do like this is the okay. All right, to do here, just to make it a bit nicer, like with the title and all that stuff, right?
Yes, and with caps on the error bars.
Caps. You mean the little
yes
lines?
Yes.
That might be impossible.
Really?
Yeah, like
no.
some things are hard.
Okay.
But it is easy in Excel, right? Like I can just send you.
Yeah, it is.
Excel. Okay, so I'll just.
It is. So alternatively, oh, you can do it in Excel then as well, huh?
Yeah, I'm not really good with Excel. I'm pretty sure
I can do it in Excel. So just tell me which data you used, and then I'll just draw it in Excel.
Yeah, so I'll send you the data.
Okay.
This we don't want to use. This. What do you think? Can you see something in this graph that you want to use?
No, because this one we already are going to draw above with the bars according to seasons. Yeah, so we all use this one. Hi, Charles.
Hi.
Cool. Wait, what do you mean with the bars according to season?
You know the first one, the blue and orange? So remember, we're going to restructure the bars into seasons, and then that way you'll be able to, we'll use that one as a seasonal one.
Okay.
Together with the heat chart.
Maybe you can do this with the colors also? I think that could be, so basically like this, but by color, by season. You know, because then you can see like each season.
Yeah, so you can make Matalai yellow, Kosi blue, like that. Just three colors, not so many, and then but exactly. The other one was
okay, so let's.
And I'm thinking.
And this is for Fibro prevalence, by the way. That other one we talked about was. Oh, but we're not doing it. Okay. Bye. Fuck. Sorry. Okay. Yeah. Sorry.
and then showing the prevalence.
What do you mean? This is the
Like,
y-axis. The prevalence.
oh, is this prevalence already?
Yes, 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 yes.
Oh.
Yes.
Okay. Huh. Yes, do it by season. And then if we do this one, then we won't have to use that other one, the one that has blue and orange. Let's leave that one out for now.
Wait, which one?
That one, that very first one you showed.
Yeah, because
This,
this,
not that one.
this, right? This you wanted.
Yes, this one.
You wanted, but I think I think it's important to see the, I don't know, like the trends in capture. At least.
Yeah, you're right.
Maybe just without,
No.
if you don't like the orange, maybe without the fibro.
No, it's not. It's not the colors. It's the bars that are bothering me. There's so many, and it's
Yeah,
okay.
we
But
take
I'm
by
trying
month,
to see.
but we can do bars by season.
We had said by season. Okay, so what we do, we'll put this one and that multicolored one side by side, yeah? So that this is the master one by season, and then the other one is like a zoom in of the prevalence by season, you know, because it's kind of small here, and then you can zoom in and someone can see it clearer.
Yeah, so it would be
Does that make
basically a graph of the orange divided by the blue. That's the next.
Yes, yeah, exactly, yeah. And then people
So
can
this
see
is
that
like
trend, the
absolute
orange trend.
numbers and then the ratios.
Yes, perfect, exactly. And then we can put it side by side. Yes, and when you're drawing them, you know, make sure you outline the bars and everything. So when you send them, you know, in black, so that it stands out, you know.
Okay. But
This is just aesthetics now, like to make it look good.
yeah, and the one for capture data.
Yeah, which you've already done up there. So this one and that one will be together in one graph.
No, it's like two different. It's like different y-axis. So yeah, two graphs.
It's fine because this is prevalence and the other one is absolute, but it's okay.
Yeah. Okay, cool.
Yeah.
Cool. Yeah, that's good. It paints a very clear picture. Cool.
And maybe you want to also specify in that graph which colors you're going to use for the seasons.
Yeah. I'll send you something and you'll tell me if you like the colors. I'll send you the default colors and we'll go from there.
All right.
But we can choose whatever colors for sure. Okay, now let's see. Ooh, this is not good. So doing a Friedman on the so a Friedman on the seasonality of Fibro, we're getting this in the ocean season. We're getting a very high p-value. Like,
what does that mean?
That there's no seasonality in Fibro according to these seasons.
Okay, that's still a result. It's not a bad thing. It's still a result.
All right. And by the land seasons, we almost have something that we can close to something.
Okay. Still a result. I'm wondering how if these land seasons are important somehow.
Like I'm thinking
Charles?
maybe that the fact that the ocean seasons, I mean, because the seasons we used before, the ocean seasons we used before, are the seasons that the fishermen go by, right? In this, or like the like Watamu goes by that seasonality, right? Or the humans of Watamu, let's say, divide the seasons in that way. So
yeah, but you see now those seasons that the fishermen use is according to the wind direction and where it's blowing, right? So we have the standard sort of times for when the winds for each season is blowing. So we still have it here, and it's showing like it's not affecting fibro, which is good to know, which means that the cause for fibro is not seasonal. It's something that's probably there all year round, in which case we're looking at another season. And I don't know why it's coming to my head, but I'm now thinking about tourist seasons. Because when you have more sewage and waste going into the creek, maybe that's when the water quality is worse in the high season versus the low season.
yeah, that makes sense.
So now,
but also like if there's a, I don't know, if there's like a 4-month delay, right, from the sewage onset to right to the disease, which I think is reasonable, right? A few months, maybe a few years even, then we won't find it in this sort of analysis, no?
well, we don't know how much of a delay there is in the disease. We don't know how quickly it manifests.
Yeah, but
And if it's
anything except for, you know, for exactly a year or exactly at that time, you know, we won't find. Like we're looking for something that is, yeah, not specifically likely.
yeah, it might be, I don't know. And I would want to hear Charles's input on this, but I'm thinking instead of using natural seasons for the land, right? We use the seasons by which certain environmental factors are at their peak. So sewage, oh man. Because the most dominant human activity in that area is hotels.
For sure.
And fishing. So we've done the ocean seasons. Now, if we look at the tourist season, it's not following the rains. It's huh? You want to add? My husband David wants to add a point. David, he's been listening.
The tourist season also brings extra pollution, diesel, and fuel into the water. All the tourist boats going out to the
Yeah, true. Oh, he's over there. He's saying the tourist season also brings extra pollution in terms of diesel and those kind of fumes from boats going out to sea, and all those tourist boats, yes, and that could be a factor. What do you think, Charles? Charles? Oh. About the hotels, most of them are not near the creek as such. I think the effect of sewage and pollution from tourists would be hard to determine, although worth considering. What about the boats and the increased activity in the ocean? All right. What do you think, Ita? Do you think you could do one more just considering the tourist seasons? That can be a factor. However, I'm worried about accounting for it as a reason of fibro, because the fibro there is now a prevailing theory that fibro is connected to environmental factors. So if the water quality goes down, then there's been several papers that have shown that there's been heightened, more prevalent cases of fibro in waters that are polluted or degraded compared to waters where there's hardly any human activity. So that's the reason why I'm looking at the tourist seasons, because that's a source of water degradation, you know, from diesel from the boats, you know, any kind of activity around that bay that is adding pollutants to the water. That's why I'm accounting for it as linking it to fibro. Does that make sense? I'm talking to Charles via the messages, although he's writing. Because if it does, and I'm starting to really think that it does, just to strengthen this, then I'm going to ask Charles to give us the official tourist seasons. You have high and you have low. There's like 2 high seasons in December and whatever, and then there's some low ones in March and whatever. I think I can get that seasonal data. So okay, cool. Thanks. Okay, Itai, you want to continue or?
Yeah, I was just thinking that maybe we should do like a different approach to the whole seasonality analysis, in terms that like we're not going to be able to find any delayed effects, and effects are likely delayed. But we could, I don't know what to research about what's the correct statistical test and how to account for this, but
time series analysis.
Yeah, because we're basically, because now we've been looking only at things that that not only happen at the same frequency as these months, but also at the same phase, right? So we need to check like different phases, like shift all the seasons in 1 month and in 2 months, so to do like 12 different checks, but then we'll have to somehow account for doing so many tests.
Yeah, exactly. So I don't know. We can the prevalence, the pattern, even this graph that we're looking at right now, is telling us something. And
Yeah.
when I look at it, it's like something happened in 2005, 2013, 2014, and 2019. What happened during those years, I would love to know, because it's triggering the fibro. But we know it's not related to land seasons. We now know it's not related to ocean seasons. So, you know, in 2013, what was going on, you know, if anything, in Watamu?
Okay. I'm trying to do this. Ta-da. So yeah, this is the
Oh,
graph.
that's much better. That's much better, yeah.
So do we see more of a certain color than another
The
one?
green is quite prevalent in several years. In fact, the green is quite prevalent in those years where you have, you know, the big prevalences, overall prevalences for fibro. 2005, 2013, 2019. But we already know it's not to do with that, huh?
Yeah.
We can use this graph and just say, Matalai seems to be, is there a way we can get an overall prevalence for each season? You know, like you write it there, mean prevalence for Kaskazi equals point something something, for Kusi equals point something something, like that.
Sure.
And then we can describe it in the results and say the highest prevalence by season was in this season. However, overall, there was no significant
looks like this.
prevailing prevalence.
So
Yeah, so Matalai is the highest. Yeah, Matalai has the highest. I'm surprised with those numbers that we're not getting a significant. Matalai is so much more than the other two.
Yeah, also more noisy.
Oh, okay.
Yeah.
What if we broke it down by month? Is it straightforward to do that?
Broke it down by month.
Hmm.
Ooh, cool, right?
Like we did an ANOVA according to months or something. Not the graph per se, but the analysis.
Sorry, what were you saying?
I was saying, what if we did the analysis according to month instead of season? Because Matalai is so noisy. Is it a particular month?
So May seems to be high.
Let me write that down. May is a month with the highest.
Yeah, and it's not exceptionally noisy. But they all have like the, you know, like really high standard deviation. But also we're looking at standard deviation and means of things which are not normally distributed. So this is actually misleading.
Yeah, exactly. Exactly. It could just, you know.
Yeah, because they look more like this. Yeah.
Yeah, that's the typical distribution for disease, by the way. That's not something that surprises me. That is very, very typical and common for a disease. It's not normal, and it's binary. It's very binary.
Yeah.
So that's fine. In fact, I'm happy to see that.
Yeah. 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 I mean, it makes sense.
Yeah.
Like sometimes things are not sick.
And most of the time things are not sick. Yeah.
Yeah. Okay.
All right. Okay. Sawa. So I think it's time now to do some takeaways from here. I've been writing notes. I think my next step now is to go back through this recording at some point and start implementing and incorporating some of our discussion into the results.
Okay. So I just want to say I'm confused about all this seasonality stuff. Like I'm not sure where to go from here.
Don't get too concerned about it. Just because we haven't got a definite answer, it's still a result. What we have is still a result, and we use the standard channels.
Yeah. Yeah, but
And
again, like what I'm concerned about is that the analysis is not like correct. Like the only thing that we can say is that by the seasons that we checked, there's no seasonality, but only if the seasonality comes, you know, at the time, you know, exactly in that time, like the disease becomes instantly, or you know, exactly 1 year or 2 years, you know, after the onset, which is just, you know,
it's difficult to do. So maybe what we can do is express that concern in the discussion. To say there could be some time series aspect to our findings, whereby the manifestation of the disease occurs in a given time period post exposure, right?
yeah. I guess the question is how to account for multiple tests on a Friedman thing, right? Because if we know that, we can just do multiple tests, and may not be super easy. But
maybe I can leave you to look into that. Do you want to look into that?
yeah, I'm putting it on top of my to-do list. This goes up.
How to account for multiple tests in a Friedman's?
Yeah.
Okay.
Let's do T. Dependent of keep forgetting that word. Phase. Okay, looks clear enough.
But you see, I'm not too worried because I've come across this before, so when I was looking at avian malaria in birds, right?
Yeah.
by the time, so there was an element of time series to it, because when it rains, then you get more mosquitoes, and then the likelihood of a bird getting malaria increases, right?
Yep.
But you found that there was a lag. There's a
Yes.
lag between when it rains to the population of mosquitoes increasing to the disease happening.
Yes.
So that can come out. It's just that we can't do it here because we don't know what the triggering factor is. That's what we're looking for. You need to know what the trigger factors are in order to be able to do that time lag thing. You know what I mean?
Yeah,
Like,
yeah, of course. If
malaria.
we know the thing, then we can calculate the lag. But I want to
Yeah,
do
and
like the opposite, right? To check all let's say 12 lags, right? If that's the resolution we're looking, like a 1 month resolution. Yeah, because if it's like exactly 1 year seasonality, then we'll find it, right? So we only need to check like 12. So to check all 12 lags and to see if any of them correspond to something. So that's easy, but then the hard, or not hard, but I just don't know how, is how to account for having done 12 tests and that one of them, but isn't that part of the p-value, right? Don't we just like divide the or something, right? Multiply the number of tests minus 1 in the p-value or something, no? I feel like
I don't know now. You've lost me there.
I mean, like, because if we're doing, there's the p-value is the chance of getting this result randomly, right?
Yes.
So if we're doing 12 tests, what is the chance that, okay, I'm halfway there. Cool. I'll figure it out.
Oh yeah, I can see what you're doing. Okay. All right. Well, so you can get back to us with that.
Yeah. Yeah. So and I'll check and I'll figure that out, the statistics, and then I'll do the test and we'll see if we get anything. Because now we have nothing. So
yes. And then I've just remembered on this bar graph here for the seasons that we're looking at, we also need error bars on it.
Error bars, cool.
Yeah, to account for the noise, especially in like Matalai and so on.
Cool. Oh, so it needs to, okay. So like monthly error bars, right?
No, seasonal ones.
Yeah,
remember how
but
you
like
said that
each season, so now each bar is made of like one season. So you want each one of these, I can do it made from 1 month, and then you'll have error bars. Okay, that's cool. I can do that. This by ocean season. Wait. Error bars. Uh-oh, we have 10 minutes.
I think we're kind of more or less finished. It's been more than an hour anyway on the meeting.
Yeah, maybe we'll just go quickly through the rest of the notebook.
Okay.
Okay. Sorry, this is so.
I'm not rushing you. I'm just saying we've covered a lot.
Yes, that's true. Oh, I already did this. Huh.
Oh, you already did it, huh?
Huh. It's a smart boy. Look nice with the title and everything. All right. So the location, right? That's the new part.
Location, yes, and then also we were going to try the tourist seasons, which Charles will give us, and then you can. That's just one more analysis, just to see if there's something there.
Yes.
Just to see. Yeah.
Okay. So what did I do here? This is the capture sites. Oh, I had like a little bug here, but basically, yeah, really good p-value for Friedman on the capture sites. So I'm doing the capture site as the right. It's like a repeated test again. So there I was testing the season, and now it's the capture sites, and still the year is the subject. Are you following, or is this not clear?
Yeah, I'm following you.
Okay, cool.
By year. Mm-hmm.
Okay, so it's the subject is the year, and the within is the capture site. So saying that most of variability will be explained by the difference in the years, right? That's why subject is year.
Right.
And we're looking for differences, like smaller differences between the capture sites. And doing the Friedman, we get like a super high p-value, which is cool and obviously expected, because we saw that some capture sites have nothing and some have something.
Let me just go back to those capture sites there. I just want to have a quick look. Okay, that's prevalence, right?
Yes.
Okay.
Prevalence. And this here is not a good title, but this here is the logistic regression. And here there's still not ANOVA. No, this is just logistic regression on the location.
Okay.
And Fibro. And yeah, so ANOVA, that was the Friedman, right? Like, oh, you mean like a,
okay.
right? So the Friedman
Right.
is our it's like ANOVA with ranks instead of using the whole. It's like ANOVA for no when things are not normally distributed.
Okay.
Yeah. So
cool. Okay.
So that's what we saw. We have a low p-value in the Friedman test. That means
which is
that
good.
Yes, that means that some capture sites have a different mean prevalence than other capture sites.
Which is like a significantly different one.
Yes.
Okay.
And then we're trying to see, right, how much each of the locations actually affects the chance of turtle having fibro there, right? And here I'm getting some weird results. So the mouth and the south of the creek have like really high p-values. So I haven't gone into this. I guess I need to understand.
That makes sense to me because that's where we had some of the highest prevalences. Kivunjeni is in the south of the creek, is in the south, and that's the one with the highest prevalence.
So why would it have a high p-value?
Showing a significant difference to the others.
Insignificant. This is a 0.6.
No,
right? So in the south and in
no,
the
it's not. It's not 0.06 or 0.05.
Nope. 0.58.
Ish.
Yeah. So I don't know. I guess this is the second thing on my to-do list, is to understand what's going on with this logistic regression.
Okay, let me write that.
Might be something with missing values, or there's always this nonsense. This is my guess about the implementation of this, because it shouldn't have like there's enough data, there's enough, I don't know, but yeah, this still needs work, but we will have results that make sense and that will tell us yeah, basically where is the most likely to get fibro.
Okay.
And the contribution of each of the locations. What else? Oh, the leeches and stuff. So it's nothing new here, and it's still the same issues like there. So we have a very high p-value on algae for some weird reason.
For this one, oh really? Like it's significant.
No, insignificant.
For this one,
Algae.
I'm thinking, why don't you
Efficient,
just
isn't it?
you know how I said concentrate on the green algae?
Yeah. Oh, yeah.
Is it possible to just include all algae?
So not just the green algae?
Just green ones? It's all algae, I think, because I don't know which species of algae are there and which species are responsible exactly, and it may not necessarily be the green algae. So
Okay, so just
that's include all algae, not
all right.
just green.
Still insignificant p-value.
It's fine.
I don't know. That's weird. There's enough data. It shouldn't do that. But okay. Cool. Okay, so let's see my action points from this. The big ones is figuring out the multiple tests and the p-values for the logit and this stuff. Actually, no. Yeah. Okay, and the graphs, yeah, it's also written here somewhere. Cool.
Okay. All right. So I've been writing a few notes down, and I will allocate tasks as required.
Cool.
I think this time the bulk of the work is you and I, Ita. Charles has one thing. The seasonal. Charles will go and check for us the tourist seasons and then send to you, share with you so that you can do that analysis. And I'm just going to start writing now on the basis of this call and the one before. Just start to put some results together. Please don't forget to send me those graphs. Let me write that.
Yes. Yes. Write it on the thing. Maybe send an email even with your notes. I think that's for me, that's the easiest way. Make sure I remember to do
an email
things.
with the notes?
Yeah.
Okay.
Just
Of these ones are written? Okay. I'll do that. I'll send an email and yeah.
Awesome.
Charles, anything you want to add when we have less than a minute left? Sorry. No, we can't hear you, but I trust that you're writing.